Dear students, in this session we are going to discuss about stoichiometry. What is it? Stoichiometry represents numerical relationship between chemical quantities in a balanced chemical equation. So it is a numerical relationship between chemical quantities. What are the chemical quantities? Suppose if carbon is burnt with oxygen, we get carbon dioxide. This is the balanced chemical equation. Numerical relationship. What is the numerical relationship between various chemical quantities? What are the various chemical quantities? The various chemical quantities of carbon in the solid form, graphite, maybe graphite, when burnt with oxygen gas, produces carbon dioxide gas. These are the different chemical quantities. What is the numerical relationship? 1 mole of carbon dioxide burns with 1 mole of oxygen to give 1 mole of carbon dioxide. That is said to be the numerical relationship in terms of number of moles. Numerical relationship may not always be number of moles. It may be with mass, it may be with volume, it may be with number of molecules, it may be with number of atoms. So, stoichiometry represents numerical relationship between chemical quantities between different chemical quantities in a balanced chemical equation. Now I set 1 mole of carbon reacts with 1 mole of oxygen to give 1 mole of carbon dioxide. I may also say 12 gram of carbon combines with 32 gram of oxygen to give 44 gram of carbon dioxide, because molar mass of course it is atomic mass, it exists in the form of atom, so atomic mass 12 gram. 1 mole of oxygen, 1 molecular mass, 1 molar mass of oxygen, 2 into atomic mass, 32 gram per mole. So earlier I said 1 mole of carbon combines with 1 mole of oxygen to give 1 mole of carbon dioxide. Here I have related in terms of mole relationship, I can say. Numerical relationship is given in the form of mole. Now it may be in terms of mass, as I said, 12 gram, 32 gram, 44 gram. Why so? Atomic mass of carbon is 12, molar mass of carbon 2 into 16, 32, molar mass of carbon dioxide 1 into 12 plus 2 into 16, totally 44. So 12 gram of carbon combines with 32 gram of oxygen to give 44 grams of carbon dioxide. I can say in that manner. Once again, based on number of molecules, here carbon, elemental state, it exists in the form of atom. Therefore, 6.023 in 10 power 23 22 is given. 6.022 in 10 power 23 atoms of carbon combines with 6.023 in 10 power 23 molecules of oxygen. 1 mole corresponds to these many molecules of oxygen to give how many molecules? Again 1 mole of molecules, which is said to be 6.023 in 10 power 23 molecules. Suppose if we go in for atoms, 6.022 can be given instead of 23. Both are same only. 6.022 in 10 power 23 atoms of carbon combines with 2 into this many, 2 into 6.022 in 10 power 23 atoms of carbon, I can say. Atoms of oxygen, I can say. Because 1 mole of oxygen, 1 molecule contains 2 atoms. 1 mole contains 2 mole of oxygen atoms. 6.022 in 10 power 23 molecules contain 6.022 in 10 power 23, 2 into 6.022 in 10 power 23 atoms of oxygen gives how many atoms of carbon? 6.022 in 10 power 23 atoms of carbon plus 2 into 6.022 in 10 power 23 atoms of oxygen. So we can relate in various manner. So the numerical relationship between chemical quantities which is found in a balanced chemical equation is said to be the stoichiometry. Now in terms of volume is applicable not for solid, only for gas. Here 22.4 liters of oxygen, 1 mole of oxygen at STP, standard 273.15 Kelvin or simply 273 Kelvin, and 1 atmosphere pressure contained as the volume 22.4 liters. 1 mole will have this much molecule. 1 mole will have this much molecule. And therefore, what can we say? When 1 mole of carbon is allowed to react with 1 mole of oxygen to give 1 mole of carbon dioxide, 22.4 liters of oxygen will react with 1 mole or 12 gram or these many atoms of carbon. Because volume we cannot express here, since it happens to be solid, 22.4 liters of oxygen combined with 1 mole of carbon or 12 gram of carbon or 6.022 in 10 power 23 atoms of carbon to give 1 mole of carbon dioxide or 44 grams of carbon dioxide or 6.022 in 10 power 23 molecules of carbon dioxide or 22.4 liters of carbon dioxide. This is said to be the stoichiometry, which gives numerical relationship between chemical quantities present in the balanced chemical equation. Now, one more example I can give. Burning of methane. Now, let us consider a reaction where all the reactants and products happen to be in the form of a gas. Methane burns with oxygen to give carbon dioxide and water. 1 carbon, therefore 1 CO2, 4 hydrogen, therefore 2 H2O, 2 plus 2, 4 oxygen we have, therefore 2 O2. This is the balanced equation and it is said to be a stoichiometric equation. Stoichiometric equation represents the different quantities, balanced form of reactants and products in a given equation is said to be correct stoichiometric equation. All right. Now everything is in the form of gas, 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 gas and gas. Water in the form of steam we consider. Now, when 1 mole of methane, let me relate in the form of mole, 1 mole combined with 2 moles, mole symbol MOL, spelling MOLE, 1 mole of carbon dioxide and 2 moles of water. 1 mole of methane combines with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. In terms of mole I have given. In terms of mass, I have to calculate molecular mass. 12 is the atomic mass of carbon, 1 is the atomic mass of hydrogen, 4 into 1. So the total mass will be 16. 16 gram of methane combines with 2 into 16. 2 into 16 is the molecular mass. 2 into 16 is the molecular mass. But we have 2 moles, therefore total 64. 16 gram of methane combines with 64 gram of oxygen. Molar mass 32 into 2, 64 to give 1 mole of carbon dioxide. For carbon atomic mass 12, 2 oxygen we have 2 into 16, total found to be 44 gram of carbon dioxide. And how much of water? 2 into molar mass of water. Molar mass of water we know it is 18. Let us calculate. 2 into 1. 2 into 1 plus 1 into 16. Always number of atoms we can place first. 2 plus 16, 18, 18 to 36. So what is it? 16 gram of methane combines with 64 gram of oxygen to give 44 gram of carbon dioxide and 36 gram of water. That's all. If it is expressed in number of molecules, 6.023 in 10 power 23 molecules of methane combines with 2 into 6.022 in 10 power 23 molecules of oxygen to give 6.022 in 10 power 23 molecules of carbon dioxide and 2 into 6.022 in 10 power 23 molecules of water. So 6.022 in 10 power 23 molecules of methane, let me write in word, methane combines with how many molecules? 2 into 6.022 in 10 power 23 molecules of oxygen. Let me write in word, oxygen, to give 1 mole of carbon dioxide means 6.022 not double 2 into 10 power 23 molecules of carbon dioxide. Molecules of carbon dioxide. And then what else we get? 2 moles of steam. That means 2 into 6.022 into 10 power 23 molecules of water in the form of gas. In the form of gas. All right? Because everything we have considered in gas. All right? Now, if we want to express in volume, everything should be gas. Since everything is gas, 1 mole corresponds to 22.4 liter or 2.24 in 10 power minus 2 meter cube. Here 2 into 22.4 liters, that is 44.8 liters. Here 22.4 liters. Here 2 into 22.4 liters. The liter can also be replaced by meter cube, 2.24 in 10 power minus 2 meter cube. This is how we relate mole, mass, molecules, molar volume, everything can be related in that way. Based upon that, it is our duty to go in for few sums. So in the next session, let us go into sums based upon this. Just try to understand this relationship. I have also given a chart showing mole, Avogadro molar mass, Avogadro number, molar volume. That relationship we should note. All right? Thank you.